Do you ever wonder what lurks in the darkest corners of the universe? Welcome to a journey through the cosmos, to the heart of the most mysterious, most fascinating phenomena known to science, black holes. These gigantic cosmic beasts, hidden in the inky blackness of space, have been the subject of countless studies, theories, and even science fiction stories. Yet they remain shrouded in mystery, their secrets carefully guarded by the very laws of physics that give them life. In the next 15 minutes, we'll be delving into the 10 most astonishing facts about black holes, a countdown that will take us from the familiar to the utterly mind-boggling. From the way they form to the role they play in shaping the galaxies, prepare to have your understanding of the universe turned on its head. Now prepare yourself as we journey into the unknown and count down the top 10 astonishing facts about black holes. Starting at number 10, let's explore how black holes form. Imagine a star, not just any star, but a massive one, many times the size of our sun. This star burns brightly for millions, even billions of years, but eventually, it exhausts its nuclear fuel. What happens next is a spectacle of cosmic proportions. The star's core collapses under its own weight, triggering a supernova explosion that blasts its outer layers into space. But what of the core? Well, this is where things get interesting. The core continues to collapse, shrinking so dramatically that its gravity becomes irresistible even to light. This is the beginning of a black hole, an entity so dense and so powerful that nothing, not even light, can escape its gravitational pull. What you're left with is a region of space where the rules of physics as we know them simply cease to exist. So the birth of a black hole is actually the death of a star. Fascinating, isn't it? Contrary to what the name suggests, black holes aren't really black. This might sound counterintuitive, but let's dive into it. You see, black holes are known to emit something called Hawking radiation, named after the famed physicist Stephen Hawking, who first proposed this theory. Hawking radiation arises from the quantum mechanical effects near the event horizon of a black hole. It's an emission of particles that happens due to the energy borrowed from the black hole's gravitational field. This energy is converted into matter and antimatter particles. One falls into the black hole and the other escapes into space. The escaping particle appears to us as radiation, a kind of energy that black holes can emit, defying their dark name. This process eventually leads to the black hole losing mass over an incredibly long period of time, a phenomenon often referred to as black hole evaporation. So in a way, black holes are not as black as you might think. Ever heard of time travel? Black holes might be your best bet. Now let's dive headfirst into the fascinating world of time dilation near a black hole. Picture this. You're floating near a black hole. To you, time seems to be ticking away as usual, but to a distant observer, your clock is ticking slower. This is time dilation, a prediction of Albert Einstein's theory of relativity. The stronger the gravitational field, the slower time passes. Black holes, with their incredibly intense gravitational pull, are the ultimate time dilators. As you get closer to a black hole, the effect amplifies. For you, minutes might pass. But for distant observers, years or even centuries could have gone by. This is the essence of time dilation. Time behaves differently, depending on where you are and how fast you're moving. So, if you ever wanted to travel to the future, now you know where to go. Not all black holes are created equal. The cosmic landscape is peppered with these intriguing phenomena, but they're not a one-size-fits-all deal. In fact, black holes come in a variety of sizes, each one as fascinating as the next. At one end of the spectrum, we have stellar black holes. These are the most common type, formed when a star with a mass around 10 times that of our sun collapses under its own gravity. These cosmic sinkholes can measure up to 20 miles in diameter. That's like fitting the whole of Manhattan into a point in space. On the other end, we have supermassive black holes. These cosmic behemoths can be millions, even billions of times the mass of our sun. They're often found at the heart of galaxies, including our own Milky Way. So, whether you're looking at a city-sized stellar black hole or a galaxy-defining supermassive black hole, remember this: from tiny to gigantic, black holes are truly diverse. Gravity is what keeps us grounded, but in a black hole, it's a whole new level. Imagine the force that keeps you tethered to Earth, but magnified millions of times over. That's the kind of gravity we're talking about in a black hole. It's so immense, in fact, that nothing can escape its pull, not even light, the fastest thing in the universe. That's right, light, which travels at an astonishing 186,000 miles per second, gets sucked right in, never to emerge again. This incredible gravitational pull is what gives black holes their name. They're black because no light can get out, and they're holes because, well, they pull everything into them, like a cosmic vacuum cleaner. So next time you're feeling a little weighed down, remember, it could always be worse. You could be near a black hole. In the world of black holes, gravity is the undisputed king. The point of no return? That's the event horizon. Picture yourself standing on the edge of a precipice, peering into the abyss of a black hole. This precipice, the event horizon, is the boundary beyond which nothing, not even light, can escape the black hole's gravitational pull. The event horizon is a mind-bending concept. It's a line in the cosmic sand, a border that once crossed changes everything. It is the point where time and space as we know them warp and twist into something completely unrecognizable. The event horizon isn't a physical barrier. There's no signpost that says you're now entering a black hole. It's an invisible line, and crossing it would be uneventful, at least initially. But once you pass it, you can't turn back. You're on a one-way trip to the black hole's singularity, the very heart of the black hole, where our understanding of physics breaks down. Cross the event horizon, and you become a permanent resident of the black hole. Did you know that black holes can shape entire galaxies? Yes, you heard it right. These cosmic giants are not just destructive forces. They also play a crucial role in shaping and influencing galaxies. Let's talk about supermassive black holes. These are not your average black holes. They are millions, even billions of times more massive than our sun. And here's the interesting bit. Almost every large galaxy, including our own Milky Way, houses a supermassive black hole at its center. These supermassive black holes exert a tremendous gravitational pull. This gravitational force influences the motion of stars and gas around them, effectively sculpting the galaxy. The larger the black hole, the bigger its sphere of influence, shaping how the galaxy evolves over time. Moreover, the intense gravitational pull of a supermassive black hole can trigger star formation by compressing clouds of gas and dust. So in a way, black holes are not just destroyers, but creators too. Black holes, the cosmic architects. When two black holes love each other very much, they merge. This isn't an interstellar romance, but rather a cosmic phenomenon that leaves even the most seasoned scientists in awe. Imagine two black holes, each with a gravitational pull so strong that not even light can escape, spiraling towards each other in a deadly dance. As they draw closer, they begin to orbit each other at nearly half the speed of light. This intense dance causes them to release energy in the form of gravitational waves, ripples in the fabric of space and time that Einstein predicted over a century ago. These waves travel across the universe, undisturbed and unaltered, carrying with them information about their cataclysmic origins. Finally, in a moment of cosmic drama, the two black holes merge into one, releasing one final burst of gravitational waves. It's a spectacular show of cosmic forces at play, a testament to the immense power of our universe, a cosmic dance with a grand finale. Seeing is believing, but you can't see a black hole. Now that's a bit of a cosmic conundrum, isn't it? Black holes are indeed invisible to the naked eye. It's not because they're shy or anything. It's just that they're so incredibly dense and their gravitational pull is so powerful that not even light can escape their clutches. So if we can't see them, how do we know they're there? Well, scientists have a few tricks up their sleeves. They can detect the effects a black hole has on its surroundings. For instance, they look for stars that are moving in ways that suggest they're being influenced by a large, unseen mass. Or they observe jets of energy and matter being ejected from areas around a suspected black hole. It's like looking for footprints in the sand. You might not see the creature that made them, but you know it's been there. Invisible, yet detectable. The paradox of black holes. At number 1, we have the singularity, the heart of a black hole. A singularity, in layman's terms, is an almost unimaginably small, infinitely dense speck of matter. Imagine taking an object of immense mass and squeezing it into an infinitesimally small space. That's what we're talking about here. In the realm of the singularity, all known laws of physics cease to exist. The gravitational pull becomes infinitely strong. Space and time, as we understand them, come to an end. Everything we think we know about the universe and how it works just doesn't apply anymore. It's like stepping into a different universe altogether. In this place of extreme gravity, even light cannot escape its pull, leaving us in the dark about what really happens inside. Scientists are still grappling with the concept of singularity, trying to reconcile it with our understanding of physics. A place where everything we know about physics breaks down, the ultimate mystery. From their formation to their mysterious centers, black holes are truly astonishing. Throughout this exploration, we've delved into their complex nature, unveiling 10 mind-boggling facts about these cosmic giants. We started our journey by understanding how black holes are formed, and then we debunked the common misconception that they are black. We also touched upon the fascinating concept of time dilation. The size variability of black holes, from as small as an atom to as large as 20 billion suns, is another feature that adds to their mystique. We've learned that their gravity is so strong that not even light can escape. We've crossed the event horizon and discovered how black holes shape galaxies. We've also witnessed the merging of black holes and acknowledged their invisibility before finally reaching the singularity, the very heart of a black hole. And there you have it, the top 10 astonishing facts about black holes. Until next time, keep looking up and stay curious. Before we wrap up, we'd love to hear from you. Did you learn something new today about black holes? If so, make sure to smash that like button. It's always fascinating to hear your thoughts and opinions, so don't hesitate to share them in the comment section below. If you're as intrigued by the universe as we are, subscribe to our channel and press the bell icon. This way you'll never miss out on our upcoming videos exploring the wonders of our cosmos. Lastly, if you found this video enlightening, share it with your friends and family. Let's spread the knowledge and the curiosity. Remember, the universe is full of mysteries waiting to be uncovered. Until our next cosmic journey, stay curious, stay inspired, and as always, keep looking up.